I got you first. That's right.
It has been a while since we've done some math. We did some trig ratios last week, and we had a little acronym. Does anybody remember it? SOH CAH TOA. Yep, that is it. SOH CAH TOA.
Now I got something to sit with.
Okay, so that acronym gives us three formulas. So the S formula would go, the sine of the angle equals, and how do you transform SO into a formula?
O over H.
The O over H. And when you're working with these letters, what did the O stand for? Do you remember that?
Opposite.
Opposite. Opposite of the angle that we're talking about. The H, what did that represent?
Horizontal.
Hypotenuse. Hypotenuse. What do you know about the hypotenuse? What's a property of a hypotenuse? Longest. What else? And it's always opposite of the 90. Okay, so that's how you transform these into that. And obviously this is cos of an angle, adjacent over hypotenuse, tan of an angle. Okay. When you're working with trig, this is so important. My grade 12 still get mixed up with it. If you have an idea of what's going on, it'll help you more. There's always three components of a trig equation. So the first component is the trig function. Okay? So you have three options: sine, cosine, or tangent. Those are the trig functions. Then you always have an angle. And it always equals a trig value or ratio. It could be a decimal, it could be a fraction. Okay, you always have those three components when you write something. So the sine of an angle equals a trig value, fraction, whatever it might be. Okay, we're going to go to our calculator, and I'm going to ask you, what is the cosine of 30? So I want to figure out what the trig value is. What is the trig value? So you're going to need your calculator here. And then do you remember when we're working with this in our calculator, we must have it on degrees at the top, or somebody might just have a D at the top of theirs? That means you're in degree mode. Okay, so what is the cos of 30? 0.866. So my backwards people, do you remember? You're good? 0.866. So like I said, it's the trig value. It could be a decimal or it could be a fraction. How do we work backwards to get the angle? So what if I make this statement? Cos of an angle equals 0.866. How do you solve for the angle? So forget the last question for a second. What if I gave you that? The cos of some angle equals this. How do I get back to the angle? Okay, so now the button on your calculator is going to be cos inverse. So can you push second shift cos 0.866? So it's going to go from a trig value back to the angle, 30 degrees. So again, I pushed second cos 0.866. Did it work for everybody? My backwards people, you got that new button? Did it work? So you're going to push 0.866 first. And then second, and then second cos. 30 degrees. Anybody calculator? Works? Okay. Okay, so let's apply this. So solve for this angle. So first of all, here's my angle position. There's O's, there's A's, and H's. 10 is which? 14 is which? Give me your letters on top of the 10. Write them down. Is 10 your O, your A, or your H? Put a letter on there. And is 14 an O, an A, or an H? According to this angle, right? You're basing everything off of that angle. So did you tell me 10 was adjacent to that angle? And 14 is a hypotenuse because it's across the 90. Okay, which method do we go with? The SOH, the CAH, or the TOA? CAH. So cos of the angle equals 10 over 14. Remember doing that last week? The cos equals the adjacent over the hypotenuse. Okay, how do I figure out the angle now? So what's the process for getting the angles? Cos inverse. And now this is the important new step. I'm going to need brackets to do that. My backwards people, you probably want to go 10 divided by 14 equals, and then cos inverse. So this is what my calculator will look like. Okay, and then my angle is 44.4 degrees. Is that what we're getting, everybody? 44.4 degree? Does it seem reasonable? Didn't work out? Make sure it's in degrees. It's microphone go into radians. Okay. We'll go one decimal place on these angles, by the way. If I had done this, do you understand that that would be incorrect?
Yes.
Because your calculator would be doing what's the cos inverse of 10? And then taking that and dividing it by 14. Do you understand that that would be wrong? So you need brackets on that, right? Because you want to do the cos inverse of 10/14. Okay, here's your angle. Give me an O, an A, an H. Give me which letters? 5 is your what? 14 is your what? So I picked an O for the 5 and I picked an H for the 14. That means I'm going to do the SOH formula. So it's going to go the sine of the angle equals the 5 divided by 14. Okay, so now if I want an angle, I'm going to inverse, and then I'm also going to put brackets on that value. Okay, and it's also acceptable if you want a different calculator method. If I do 5 divided by 14 and then second inverse that answer, it also would get me there, right? That's another method. Okay, let's set this next one up. Give me OAH letters on my 6 and my 7. Put a letter on the 6 and the 7 for me. Either an O, an A, or an H. So I picked 6 with an O and 7 with an A. Opposite and adjacent sides. So that means I'm going to be using the TOA method. That's what you're all picking. So tan. So tan of this angle equals the what over the what? Okay. Solving for an angle, that means you inverse, and then you'll want that in brackets again. $40.6 matched. I'm getting, yeah? Anybody match my answer? Yeah?
What is like the tan -1?
Tan, so go shift, like second.
Yeah,
Did you push
second
second, tan?
Yeah.
That. And then did you do brackets? Did you remember your brackets?
Bracket 6 divided by 7.
Yeah.
Got 0.7.
Okay, your mode. Go back up here. What does it say at the top?
Oh.
How
it
did
says
you?
rad.
Yeah. So that's why.
What do I have to press?
I don't know. I have a mode button there.
D or G?
Yeah. You have something.
Okay, got it.
Okay. Does it say D or a G?
G.
D E G at the top. Yep. How did you get out of that? Were you in it degrees on the other ones?
No, me and Wes did this when last week, but I
Oh.
forgot how we did it.
So somehow your calculator switched on you.
Yeah.
Okay. Can you do this one on your own? Let's see if you can get this 2/5 one. Go for it on your own. See if you can put the letters in and then get the angle. Anybody feel super confident in their answer that they want to shout it out? 66.4?
I didn't shout, I got it right.
That was, you're confident.
I'm not confident.
Okay. Next one. So this is the angle. And then 13 would be adjacent, and 12 would be hypotenuse. That means I'm picking a CAH method. So cos of the angle equals the 13 over the 12. Which means my typing would look like that. Cos inverse of, and then that of that fraction. And what is your calculator telling you?
Math error.
An error. Are we getting that? That is correct. There's a problem. What is wrong with this triangle?
The hypotenuse is not possible.
Yeah, this is impossible to have that side be shorter than that side. And that's why it came out as a math error. Does that make sense? That's an impossible triangle. You can't have that inside a triangle. Okay, so the hypotenuse has to be the longest. Has to be the longest. That's why it was not working for us. Okay, solve for everything. I need you to get me every side, every angle. Okay, what do you want to get first, the x, the y, or the z? The y. Okay, so if I want the y, I would pick the opposite and adjacent sides to the y. Okay, that means I would do TOA. So the tan of angle y equals the 17, opposite 17, over adjacent 10. So that's a tan inverse to get an angle. Okay, I think I would like to tackle x next. What's your best method? There's lots of methods you could use. What's the quickest one to go with? Anybody see a quicker method to find x?
Y plus 9t.
Yeah,
Then so
you need to add to 180. Yep. This, and this, they need to make 180. So if you have 90 and 59.5, what's the last one going to be? So 180 minus all the other angles leaves you with how many degrees for x? Okay, and the last thing is the z. We can do multiple things to get z. What would your first instinct be to get this side? Something we've learned. Yeah, the theorem. The a squared plus b squared equals c squared theorem. So, here's my question. Would you want to add because you were finding a longer side, or would you want to subtract because it's a shorter side? Which method would you pick? Add. So 10 squared plus 17 squared is 389. But don't forget, you still have to square root it, right? So usually, I should tell you this, my rounding rule is everything is usually 2 decimal places, but I will go 1 on angles. Okay, I'm going to make you solve for Z in another way, just to show you that it also is going to work. All right, can you, let's go with, if I knew this one was 30.5, can you pick me some kind of SOH CAH TOA ratio? And I'm going to use the 30.5 corner, because you can use whatever corner you want. You could have used the 59.5, but I'm going to pick this one. What do you want to use? Do you want to use SOH or CAH? CAH, okay. So if I was to use the cos of 30.5, it would equal the adjacent 17 over hypotenuse Z. Do you remember, this was last week, how to solve? So, remember my first instinct was just to put that over 1? And then I always said, what diagonally multiplies, and then divide the other thing. So the diagonal multiply is that divided by that. Multiply, divide. Do we get, hopefully, the same answer?
Close. 19.73.
I got 19.73. Yeah. So when I have this test question, do you understand that you and your neighbor could have like 6 different ways to do this? I could have also done, I could have done the sine with 10 and Z. Then I also could have done the other angle. So there was 5 ways, different ways just to get Z. Okay? All right, let's try this one then. Last one. Okay, we can get angle X very quickly. What are you going to do to get angle X? It's worth 1/2 of a point. What are you doing to get it? Angles subtracted, yeah. So you've already figured out my short method. So why was he saying 90 minus 28? Because if they all add up to 180, but there's already 90 degrees in there, what do the other ones always make? 90 together, right? So it is 180 altogether, but in a right triangle, these two will always add up to 90 because there's another 90 in there. That's how you're always making 180, right? What? I got, oh, I got 62 here.
No, like the 90.
Oh, I just, like, yeah, if they were the same, they'd both be 45, yep. Sorry, I was just drawing a random diagram. Okay, 62. That's good. Okay, you can't use Pythagorean theorem right now. Do you see that? You can't. To use it, you have to know 2 sides. So it's out. So what do you want to do? We got to use something SOH CAH TOA. So I'm going to use this 28 degrees and this 5. What do you want to get here? The Y or the Z? Doesn't matter to me.
Z.
The Z, okay. So if you were to use those 3 pieces of information, can you set me up some kind of SOH CAH or TOA ratio? Think about your O, your A, or your H. What do you all have here? So, if I'm using the 28 degree, then 5 is the O. If you were using the 62, you can totally use the 62, but then you're using the CAH, right? It would switch. But you're going to get the same answer no matter what. Okay, so sine of 28 degrees is a 5 over a Z. Okay, then I put that over 1 just to help myself. Crisscross. Which ones multiply, which ones divide? 1 and 5 times divide. What? This doesn't make sense. I did not. That doesn't even make sense. 10.65. That makes more sense. You know why I knew I was wrong? Because I'm a math teacher? My hypotenuse. I was like, why? How is my hypotenuse smaller? So then I'm like, wait a minute, I did something wrong. Which you would have done on a test, right? I don't know what I typed in. There. That looks better because it has to be bigger than 5. What do you want to do to get Y? We got lots of options here. You can do Pythagorean theorem with add or subtract. You would do a subtract, and or you can set up some other SOH CAH TOA ratio again. We've got lots of ways to solve it now. Okay, I just did it with a Pythagorean theorem, and I just did it with a SOH CAH TOA ratio, and it didn't matter. They both got me to the same thing. Okay?